So on number 19 from section 2.5, we want to write the equation of the line in slope-intercept form and standard form that has a slope of 7 and passes through the point 0, negative 6. Now this is our m, the slope, which is 7, and b is the y-coordinate of the y-intercept. So whenever a point has x as 0, that point is a y-intercept. So this actually is the y-intercept. The y-coordinate of that point is our b. So the slope-intercept form of our line is y equals mx plus b. So in this case, that's y equals 7 times x plus a negative 6, which is the same as adding a negative 6 is the same as subtracting 6. So that's our slope-intercept form of our line equation. Now to put this in standard form, we will add a negative 7x to both sides of the equation. So we have negative 7x plus y equals negative 6. And that is our standard, one of the equations that fits the description of the standard form. Remember, that form is not unique. If I multiply this by any non-zero constant, I'll get another standard form for the same equation. Only the slope-intercept form is unique. All right, in number 22, we have the same task. We want to write the equation of the line that has slope 0 and y-intercept 3, and we want to write it in standard form as well as slope-intercept form. So our m equals 0, our b is 3, and we know y equals mx plus b, so y equals 0 times x plus 3, y equals 0 plus 3, 0 times x is just 0, so y equals 3. This is our slope-intercept form of our line equation. And it's also our standard form in this particular case, because a is 0. So remember, the standard form is ax plus by equals c. In this case, a is 0. So 0 times x plus 1 times y equals our c of 3. So notice in the standard form, for this particular special case, a is 0, b is 1, and c is 3. All right, let's find an equation of the line passing through the given points. We want to express our answer in slope-intercept form. Well, we have 2 points. So whenever we are given 2 points and asked to find our line equation, our first step is to find our slope. And remember, each y is put in the numerator over its corresponding x. So y goes in the numerator, x goes in the denominator, and then I subtract. So 16 minus a negative 17 is the same as 16 plus 17. 6 minus a negative 5 is the same as 6 plus a positive 5. So this is 23 over 11. That is our, I'm sorry, 33 over 11, sorry. That's our slope, and that simplifies to 3. All right, now once I find my slope, I just need one of the points, and I call that point x1, y1. So I'm going to use the point 6, 16. So x1 is 6, y1 is 16. So the point slope form of our line equation is y minus y1 equals the slope times x minus x1. So y minus 16 equals 3 times x minus 6. And we'll use the distributive property here. Y minus 16 equals 3x minus 18. And we will isolate y by adding 16 to both sides. And we get y equals 3x minus 2. So that is the slope-intercept form of our line equation. Here we want to find the equation of the vertical line that passes through the point 3, negative 3. Remember, on a vertical line, all points have the same x-coordinate. So the equation merely tells us about x. So this equation is x equal to 3. So all points on a vertical line have the same x-coordinate. And if one point has an x-coordinate of 3, all the points have an x-coordinate of 3. So this is the equation of our vertical line, x equal to 3. Y varies and assumes all real number values. But x, in order for a point to lie on that vertical line that we're describing here, x must be 3. Okay, so we're given this line L1, whose equation is y equal 1/3 x plus 1/2. And we want to find L2. Here's what we're told. L1 and L2 are perpendicular to each other. Oh, no, parallel. So here's the symbol that says is parallel to. L1 is parallel to L2. And L2 passes through the point negative 5, 4. All right, so that means we have our slope. Now notice L1 has slope M1 equal to 1/3. The line we're trying to find, L2, is parallel to L1. So that means these two lines have to have the same slope. So M2 is 1/3 because our line we're trying to write the equation of is parallel to L1, so it has to have the same slope as L1. All right, so we're going to use the point-slope form. We want to eventually get to the slope-intercept form. So the point-slope form says y minus y1 equals m times x minus x1. So this point that L2 passes through is our point whose coordinates we'll label as x1, y1. So we have y minus 4 equals 1/3 times x minus a negative 5, which is the same as y minus 4 equals 1/3 x plus 5. So the instructions say type an equation using slope-intercept form or using the given point in point-slope form. So this is point-slope form. And then typically the problems, because of the way the instructions read, I could either give the slope-intercept or point-slope form. So here, if I was in my math lab, I could stop right here and enter this as my, as my answer. If I wanted to do the slope-intercept form, I would have to, of course, keep going. So I'm distributing this 1/3. I multiply 1/3 times x and 1/3 times 5. And then I'm going to add 4 to both sides. So y equals 1/3 x plus 5/3 plus 4. 4 can be changed to a fraction whose denominator is 3 by multiplying it by 3 over 3, which is just 1. So this has added to it 12 over 3. So y equals 1/3 x plus 17 over 3. And that would be the other answer that would have been accepted. So I could also have entered this, the slope-intercept form, according to the directions. Now our last problem is the problem where we want to write a line equation that is perpendicular to the line. We'll call this line L1. Y equals 5, 6x plus 1. And notice the line we're trying to find, we're going to call L2. L2 is perpendicular to L1. So this symbol means is perpendicular to. And L2 passes through the point -2, 1. All right, well, we can see that for the given equation, that equation represents a line whose slope is 5, 6. So we'll call the slope of line 1 M1. Well, that means the line we're trying to write the equation of has a slope that's the negative reciprocal of that. So if this slope is positive, then the slope of the line perpendicular to that is negative. And I invert, so I change the sign and invert. So M2, the line we're trying to find the equation of, has slope negative 6 over 5. Okay, so I now can use my point slope form of my line equation. Y minus y1 equals slope times x minus x1. And x1, y1 is this given point. So y minus 1 is negative 6 over 5 times x minus a negative 2, which will be x plus 2. And so you could stop here and enter this as your answer. If you wanted to keep going, you would have to distribute the negative 6/5. So you, on the right side, you would get negative 6/5 x minus 12/5. 2 times negative 6/5 is negative 12/5. And then you would add 1 to both sides. So we would have y equals negative 6/5 x minus 12/5 plus 1. And we would multiply the top and bottom. We need the denominator to be 5 so we can combine these like terms. So we would multiply 1 by 5 over 5. And we think of 1 as 1 over 1. Anytime we have an integer, we can always make it a fraction by putting it over 1. So negative 12/5 plus 5/5. And I now have y equals negative 6/5 x minus 7/5. So that would be the slope-intercept form of my line equation. And this could also be entered as an answer. The instruction said either enter the point slope form or the slope-intercept form of the line equation.